Hello, this is today's lecture for Managing Technological Change and Innovation. This is Lecture 2, Sources of Innovation. Today we'll be discussing the following topics: creativity, transforming creativity through innovation, R&D by firms, firm linkages with customers, suppliers, and competitors, university and government-funded research, private and nonprofit organizations, and innovation and collaborative networks. You can pause the video now to look at the camera pill case. Additional materials will be provided on it. We will return to these discussion questions later. How does innovation happen? What are its sources? Innovation comes not from any single source, but from connections between people and institutions. There are many definitions of creativity, but I like this one. Creativity is the ability to produce work that is useful and novel. Individual creativity can be expressed in the following ways: through intellectual abilities, through knowledge such as understanding a field, a style of thinking, through personality, through motivation, or through your environment. Organizational creativity is the combined creativity of all of the people in an organization and how the organization taps into their creative resources. There are many ways for a company to do that, such as an idea collection system, social networking, or just through its culture. Innovation combines creativity with resources and expertise. Look at the last bullet in the inventors section. Individual inventors will often create solutions to their own problems, but they won't try to turn it into a business because their expertise lies elsewhere. What problem did the Segway solve? This is kind of a weird question because the answer is it didn't really solve a problem. Transforming creativity into innovation. Companies innovate because they believe it is what their customers want, while individuals innovate because they live with products or a problem every day and are motivated to fix it for themselves. User innovation, the birth of the vertical skateboard. A great example of user-driven innovation is the snowboard. Even though ski companies had the greatest capability to invent the snowboard, they didn't. Instead, Tom Sims invented a ski board because he couldn't skateboard during the winter. All the standard snow equipment manufacturers didn't know this need existed, so how could they create the snowboard? How do firms transform creativity into innovation? They have R&D departments. Within research, there are two areas of focus: basic research and applied research. The goal of basic research is to increase understanding on something without thinking about the commercial applications. A good example of this is the Large Hadron Collider. While new products may result from the research being done, that is not the main goal. An example of applied research would be in flexible materials used to make new high-definition touchscreens. Development is the application of knowledge to produce or improve devices, materials, or procedures. Look at these two lists. As you can see, on both of them, internal R&D ranks very highly. Firms follow, often simultaneously, two paths for R&D. The science push path begins with a discovery which leads to a marketable invention. For example, Post-it notes. The glue was invented accidentally and then it was turned into a product. The demand pull path is the opposite. Customers tell you about an unmet need, and then a product is invented to meet that need. This is a very basic look at the paths to innovation, and this is by no means an exhaustive list of how new things are created. This chart shows how important outside knowledge is to companies. Without this collaboration, it is unlikely firms would be as innovative. Linkages are important because they expose in-house R&D workers to new ideas. If a firm has strong absorptive capacity, then it will better use information obtained externally. All the links in the world are great, but if a firm has no way to use the information, then it is wasted. How universities and governments interact. Public universities are allowed to profit from the inventions they create, even though their funding may come from tax dollars. This motivates them to invest in innovation capabilities because they will be able to profit. Like for-profit companies, nonprofits do in-house R&D and fund outside R&D. Just because they are a nonprofit also doesn't mean they don't have much to invest. In 2006, collectively, U.S. nonprofits spent $10.5 billion on research and development. Collaboration can exist in many different ways. For example, joint ventures where both companies apply resources for the betterment of both, research associations hold conferences to exchange ideas, or even more informal networks like clubs or meetup groups. As firms, universities, government agencies, and nonprofits create relationships, they weave into a much larger network. This informal network transfers information and ideas across all organizations. As firms change over time, so does the structure of the network. Technology clusters are regions that have a high concentration of firms working on a common technology. The benefits of clusters are huge. Increased value of local labor pool, firm closeness leads to knowledge exchange, suppliers and distributors are near their clients, which reduces costs, and there are many other benefits. The likelihood of innovation being geographically located depends on three main factors. First, the nature of the technology. Is the underlying knowledge base protected by patents and/or copyrights, or can the information be passed along freely? 2. Industry characteristics. This means where in its life cycle is the industry? Are suppliers available? And what are transportation costs like? And 3. What is the cultural context of the technology? Can the local population support a cluster? Is the right infrastructure in place? And how is the technology funded? Technology spillover. This occurs when the benefits of research in one field positively affect another field. For example, the research on 3D printing has affected nearly every other industry, from hardware prototyping to fashion.